Sunrotor Solar Products here, and today we're going to talk through how to wire a float switch into one of our Sunrotor controllers. We are using the SJE narrow angle single pole double throw float switch in our M50T controller, which is what you're seeing here. Let's start with the layout. You'll notice the P plus and P negative terminals. Those are your solar panel inputs. Next, we've got the 3 pump terminals. Terminals 1, 2, and 3. After that, you'll see COM2 and TH. Those are for your tank full sensor, and that's what we'll be wiring today. Over on the far right, you've got COM1 and WH. That's your low well sensor input. Since we're not using a low well sensor for this demo, we've gone ahead and jumped that circuit to bypass it. Let's discuss the difference between those sensors. The tank full sensor uses a normally open circuit, so it doesn't need a jumper to function. The low well sensor uses a normally closed circuit, so it does need a jumper or an actual sensor wired in before the controller will power the motor. That's why we recommend the SJE Rhombus single pole double throw float switch. It gives you both normally open and normally closed functions in one switch. You'll see it has 3 wires instead of the typical 2. For this setup, we're wiring into COM2 and TH, which is a normally open circuit. So we're using the black and white wires from the float switch. If we were wanting to wire it to a normally closed circuit, we would use the red and white wires. Always be sure the power is off before making any connections. As you can see, we've used the black and white wires. The red wire can be trimmed and stowed away safely. Once wired, we powered up the controller using solar panels. The red light is our tank full light. The green light shows the system is running properly. Now we're simulating an empty tank to demonstrate how the system reboots. The tank full circuit has a built-in 3-second delay. It's not adjustable. After 3 seconds of state change, the controller will turn on or off accordingly. The low well sensor, on the other hand, is tied to the timer knob. Once triggered, the system won't restart until the timer runs out. We recommend setting it for 15 minutes. You can adjust that right here. Now, there's a more advanced version of this setup. This is useful if you aren't using a low well sensor and you'd rather tie the float switch into the input instead. Let's walk through how that works. In this scenario, we'd be using a normally closed float switch. We're showing that here with the red and white wires. And if you do have a low well sensor already connected, there's a way to piggyback the float switch onto the same circuit so your system can respond to both conditions. Start by disconnecting one of the wires from COM1. Next, take any 2 wires from the float switch. It does not matter which colors. Twist those 2 wires together, cap them off with a wire nut or something equivalent. Then connect the remaining float switch wire to COM1. What you've just done is placed the float switch in series with the low well sensor. Now both switches run off the same timer logic. If either sensor trips, the low well light will turn on, and once the condition returns to normal, the timer begins its countdown before restarting the pump. Watch it happen here. The low well sensor is tripped, and when we lower it, simulating an empty tank, 3 seconds later, the indicator light starts blinking. That blinking means the timer is active. If you want to reset the timer, simply turn the timer knob to 0. The controller will recycle and the pump will begin running again. Just don't forget to set it back to 15 minutes. That's our recommended default. And that's how we wire both low well and tank full switches using a Sunrotor controller.